In our last lesson, where we looked at the modifications of Dalton's atomic theory, we mentioned that the existence of subparticles in the atom confirmed to us that the atom is indeed divisible. These subparticles we called the proton, neutron, and electron. The question on our minds at the moment should be, how were these particles discovered? In this lesson, we'll look at the experiments that discovered the electron. J.J. Thompson, while working on gases, found out that, contrary to initial propositions, that gases cannot conduct electricity. At very high voltages and very low pressures, they could conduct electricity. To try to illustrate this, he carried out an experiment that is today known as the cathode ray experiment. I'm sure that a cathode ray tube is strange to most of us here, but it was very popular in the old days. It was the display used for televisions, monitors, and other screens. In fact, show your parents these pictures and I'm sure they will recognize it. Unlike the liquid crystal display tubes in our flat screen televisions these days, what Thompson did was to get a cathode ray tube containing a gas with very low pressure, about 0.0001 atmospheres. He bombarded the gas in the tube with a voltage of about 15,000 volts and immediately noticed a sharp green glow in the screen of the tube. He concluded that this green glow was due to the presence of a certain type of ray that can travel in a straight line. This ray he called a cathode ray. To learn more about this cathode ray, he placed a metal that was positively charged and another that was negatively charged on opposite sides of the screen. This he did to determine the charge of the cathode ray. When he passed the same voltage through this cathode ray tube that was already set up, the green glow was noticed very close to the metal plates with a positive charge. This confirmed that the cathode rays had a negative charge because it is fact that opposite charges attract while like charges will repel. Just like the north poles of a magnet will repel while the north and south poles will attract. He found out subsequently that these cathode rays were not just in gases but in all forms of matter. He called them a fundamental particle of all atoms and named them electrons because they were responsible for the conduction of electricity. Thompson described some properties of these electrons. He said that 1. They had a negative charge. 2. They traveled in straight lines. 3. Their movement was the primary condition for electricity. And 4. The charge to mass ratio of these electrons from his discovery was 1.76 times 10 raised to the power 11 coulombs per kilogram. This value was used to find the mass of the electron after R.A. Millikan in his oil drop experiment gave the charge of an electron. The mass of the electron was found to be so small with a value of 9.11 times 10 raised to the power minus 31 kilograms. This value is approximately the mass of an ant divided into 1 trillion pieces 3 times. In fact, it did not even have any effect on the overall mass of the atom. This discovery helped Thompson gain widespread fame as the man that discovered the electrons, and it probably got to his head because immediately he proposed a model of the atom from his discoveries. He said that the atom was a positively charged sphere with electrons embedded in them. Trying to explain his model of the atom, some people said it was just like a plum pudding or what we call a raisin bread. The mention of food is getting me hungry. Anyway, he explained that the atom was like a plum pudding with the positive charges being the pudding and the electrons being the plum or the raisin. This model was believed for a while until Rutherford came up in 1911 and exposed the flaws of the Thompson's model. We'll look at the Rutherford's model and how he came up with this model in the next lesson. Trust me, you will not want to miss it.